We've looked at arithmetic series is when we're adding terms that have an adding or subtracting pattern. Now we're going to look at geometric series. And remember, geometric means there's a multiplying or a dividing pattern. So they want us to find the sum of 8 terms for this. And again, 8 isn't an unreasonable number, so you could just write out the 8 terms and add them. You'd have to be really careful not to make a mistake, and I could very well on a test or a quiz say find the sum of 100. So I want to make sure that you know how to use the formula. So in this case, a is 2 because that's our first term. R, or the common ratio, is -2 because that's what we multiply each time. Now there's actually two formulas that you can use. You can just use one of them, but it just makes calculations easier if you use this one if the ratio is greater than 1, or this one, and it just reverses the order of the R and the 1 on top and bottom. And again, if you were memorizing formulas, you could just memorize one of them and it will always work out. But in this case, our ratio is -2 and -2 is less than 1. So to find the sum of 8 terms, I'm going to use this formula. So sum of 8 equals 2 times 1 minus -2 to the exponent 8 all over 1 minus -2. And I'm careful to put the -2 in the bracket to make sure I get the signs right. So that 2 is going to stay on top. I'm going to do the bottom. 1 subtract -2 becomes 1 plus 2, which is 3. This is going to be 1 minus -2 to the exponent 8. I know it has to be a positive number because -2 to the 8 is even. Or sorry, the 8 is even, which means all the negatives will pair up, but it's 256. So I get 2 times -255 divided by 3. 1 subtract 256 is -255. And to do this in my calculator, I'm just going to go 2 times -255 divided by 3, or not bother typing the negative and know that my answer will be negative. But when I add them all up, they will get -170 because the negatives are going to keep getting bigger as well as the positives. And when I add it all together, I'll end up with -170. For the next one, A is 1. R is 0.5 because that's what I'm multiplying. And I like to say to my students that math is monkey see, monkey do. Monkey see decimals, so monkey's allowed to do decimals. I tend to avoid decimals unless I see them in the original question. And if you had a hard time spotting that R, you could just do our backwards dividing. 0.5 divided by 1 is 0.5. 0.25 divided by 0.5 is 0.5, and so on. So there is our common ratio, either found by looking at it or by doing the division. And again, n is still 8 because this is all part of question 1, in which we were asked to find S8. This R is less than 1, so I'm going to use the same order as the formula that I used, where the R actually comes after the 1. So A is 1, R is 0.5, n is 8. I don't really need that 1 there. I just put it there by accident. But this is going to become 1 minus 0.5 to the exponent 8 is 0.0039065. I probably wouldn't write that in my calculator. I would probably just kind of type this in from here. So then I'm going to do 1 minus that number divided by 0.5 to get 1.9921875. Instead of a list where we can see A and R in this case, I'm given two terms. So because these are T's or terms, I'm going to go back to the general term formula for geometric series. I'm going to use these two facts to set up equations. So when n is 2, the answer is 5. So 5 equals AR to the 1, 2 minus 1. When n is 5, the answer is 625. So 625 equals AR to the 4 because 5 minus 1. This gives me A as 5 divided by R. I have two equations. I'm going to sub into the second equation. So I get 625 is 5 over R times R to the 4, which gives me 625 equals 5R3. R4 divided by R1. You subtract exponents to get R3. I'm going to bring this over and divide. So 625 divided by 5 is 125, and the cubed root of 125 is 5. You can either do that in your calculator using the cubed root of 125, or know that 5 times 5 times 5 is 125, so it takes 3 5s. Now that I know what R is, I bring it over here, and I get A is 5 divided by R, which is 5, so A is 1. So now, because R is greater than 1, I'm going to use the formula that has the Rn first on top and bottom. So I get 1 for A times 5 to the 8 minus 1 all over 5 minus 1. Remember, this is still asking us, because it's part of question 1, to find the sum of 8 terms. Don't really need to worry about that 1 in front. I have a 4 on the bottom. I'm going to, in my calculator, go 5 to the exponent 8. So 390, 625 minus 1. You can type this in one step. Just be careful that your calculator doesn't do 5 to the exponent 7. It has to do 5 to the exponent 8 first, then subtract 1. So sometimes I prefer to see it all out, but you end up with 390,624 divided by 4, which gives me 97,656 is what 8 terms of this geometric series would add to. Here we have a geometric series where A is 6, R is 3, and the last term is 39,366. In order to use our formula, and again this is greater than 1, so I'm going to go into the formula where the Rn actually comes first, but I need to know what n is. So I need to know what n is associated with this last term. Because it is an individual term and not a sum, I'm going to go to my term formula where 39,366 is the answer when A is 6 and R is 3. Remember, I do not multiply the 6 and the 3 together. Rather, I bring the 6 over and divide it to solve. So 39,366 divided by 6 gives me 6561 equals 3 to the n minus 1. That tells me that this is a power of 3, and I just need to figure out what the exponent is. You can go in order, 3 squared, 3 cubed, 3 to the 4 till you get there, or you can guess and check. I'm going to try 3 to the exponent 6, which is too small, so I'm going to go 3 to the exponent 8, which actually works. So 3 to the 8 equals 6561. So instead of 6,561, I can have 3 to the 8th. Because I have two powers where the 3's are the same, because they're equal, the exponents, or the 8 and the n minus 1, have to be the same as well. So that tells me n is 9. Now I can actually do the question because I have all the information. I'm looking for the sum of 9 terms, which is 6 times 3 to the 9, subtract 1, all over 3 subtract 1, which gives me 6, 2. I'm going to do 3 to the exponent 9, then subtract 1. Careful that my calculator does not do 3 to the exponent 8, that it does the exponent first, but when I do that, I get 19,682. So you can go 6 times that divided by 2, Or I like to type in as little as possible. So I'm going to go 6 divided by 2 first, which gives me 3. And I'm just going to multiply that number by 3 to get 59,046.